Hi everyone, I hope you're well. Today we're going to talk about chords. So grab your note packet if you've been filling it out as we've been going and follow along as we work through this. Otherwise, just pay attention and listen, and you can rewind and rewatch sections if you need to, and then email me with any questions you have, okay? So chords. A chord is a segment with endpoints on the edge of a circle. Okay, so let's look at that. Let's look at this circle over here and determine which of these fit that definition. So segment SQ. S starts on the edge of a circle, but then it just goes to the middle here, right? So it doesn't have both endpoints on the edge of the circle, so that is not a chord. RT, right? RT starts on one edge and goes all the way across, right? And it has both endpoints on the edge of the circle, so that one is a chord. Okay, and I'm going to just erase that. TQ, again, T starts on an edge, but it ends in the middle, so that is not a chord. RS has an endpoint here and here, right? So both endpoints are on the edge, so that one is a chord. And then last one, TU, same thing. It has the edges, the endpoints on the edge of the curve, right? So that is also one. So we have three chords here: TU, RS, and RT. Okay, all chords. Cool. Right. Julian thinks RS is congruent to UT. Explain why he is correct using previous theorems and ideas. So we want to think of triangle congruency, right? We want to see, is RS and TU congruent by stuff that we already know? Well, first thing we know is we know that SQ is congruent to RQ, which is congruent to TQ, and that's congruent to UQ, right? All four of these segments here are congruent because they're all radii. So all radii in a circle are congruent. Okay, and we know that. The other thing we know, looking here, is we can tell these angles right here are congruent. We know those angles, so angle SQR is congruent to TQU, so this is all going back to the beginning of the year by the vertical angle theorem. Okay, well now we have side, angle, side, so we have enough to say these triangles are congruent. So triangle SQR is congruent to triangle TQU by side, angle, side, right? And then now that we've proven the triangles are congruent, we can say RS is congruent to UT by CPCTC. Cool. So Julian was correct there, okay? All right, theorem 10.3 and its converse. Two chords in a circle are congruent if and only if their central angles are congruent. Okay, the converse of this statement would be true as well. Two central angles are congruent if and only if their two chords are congruent. Okay, so both the regular and the converse, both of those are true here. Same is true with this one. Two arcs in a circle or in congruent circles are congruent if and only if their chords are congruent. Okay, and again with this one, the converse is also true. So two chords are congruent in a circle or incongruent circles if and only if their arcs are congruent. Okay, so both are true. All right, so let's use that to kind of look at some more theorems and kind of keep going. So theorem 10.5, two chords, so chord DC and AB, are equidistant from the center of a circle or from congruent circles if and only if they are congruent. So we see that DC is this amount, this length SF. AB is also that same length, right? These are marked as the same. So therefore, we know that those two chords are equal. So AB is congruent to DC, right? Two chords are equidistant from the center of a circle if and only if they are congruent. And the converse is true. So two chords are congruent if and only if they are equidistant. And we see their equidistance here, right? All right. A diameter is perpendicular to a chord if and only if the diameter bisects the chord. Well, we see here that the diameter DC bisects this chord AB. So therefore, we know that DC is perpendicular to AB, right? Okay, and then last theorem here, a perpendicular bisector of a chord contains the center of the circle. So here I see DC bisects AB, right? It's also perpendicular to AB, so I know DC is a diameter. I know it goes through the center, so we know S is the center. Whoops. S is the center of the circle. Great. Well, let's try this next one. So are angles BAC and EAD congruent? How do you know? Okay. Well, we see that chord CB and chord DE are marked as congruent. Those are given, right? So we know CB is congruent to DE. That's given. It's marked on there. And then we see that A is the center, right? There's a dot here. So I also know that BA is congruent to DA, which is congruent to CA and EA. Right? All of those are congruent. Again, all radii are congruent. Now, if all radii are congruent, right, we can mark this now showing all of these are congruent. So all of these lengths here are the same, and it's good to mark up your diagram as you go so you can kind of see what you've done. All right, so now we have all three sides marked as the same, so I can now say triangle ABC is congruent to triangle AED by side, side, side. And if all three triangles are, or if both triangles are congruent, then BAC is congruent to EAD by CPCTC. Cool. All right.